I want to show you two questions which are very, very similar. The first question here is going to be taking the word kitchen, which if you look at it is a 7-letter word. Okay, so you got 7 letters to deal with here, but you don't have any repeats. In the next podcast, I'm also going to take a nice word, but I'm going to throw a whole bunch of repeats at you and see how the two differ. So I want you to compare these two podcasts, this one and the next one, and see how they differ because of repeats. Okay, so the first letter here says I got kitchen. Great, 7 letters. I want to know all the possible arrangements if there's no restrictions. So you know and I know, if you do this fundamental counting principle way, you've got 7 arrangements here, 7 choices for the first one, 6, 5, 4, 3, 2, and 1, which we know is 7 factorial. So if I put that into the calculator now, 7 factorial, boom, I get 5,040 arrangements of this particular thing. 5,040 arrangements of the word kitchen. Woohoo! Okay, something to figure out on the weekend, right? Okay, now let's start throwing some restrictions out here. Now, if I throw some restrictions at this thing, you'll notice one thing. No repeats. There's no repeat letters. There's no 2 Ks, no 2 Ts, no 2 Cs, and so on and so forth. But the restriction is I want K, C, and N to be together. Okay? So in other words, I want K, C, and N. And think about this. K, C, and N together. How many different arrangements can I have of K, C, and N? If you think about it, 3 choices for the first, 2 choices for the next, 1 choice for that. So in fact, I have, wherever I see KCN now, I have 3 factorial. Well, you can't see that very well, so I'm going to just clean that up. There's KCN again. I'm going to have 3 factorial choices for KCN. That's really, really critical. 3 factorial choices. Now, the other cool thing about this is the following. Check this out. This is really, really neat. How many letters do I have left? Think about it. If I used up 3 letters here like I did here, look how many letters I have left. 4, 3, 2, 1. Right? So, check it out. 1, 2, 3, 4. I got 4 times 3 times 2 times 1. But this becomes one of those and or statements. Think about this. I have 3 letters KCN up front here. That thing could be in that position, or I can have maybe the KCN in the second letter position. Oh, well, that means I have still 4 letters to deal with this choice. 3 here, 2 here, 1 here. This is still 3 factorial. That's the KCN. Or I can have the KCN in the third position. There's my KCN here. Don't forget, that's a 3 factorial, right? And think about it. 4 choices for this position, 3, 2, and 1. Or I can have the KCN in the second last position, which is still 3 factorial, which means this is 4, 3, 2, and 1. Or I can have the KCN in the last position. 3 factorial still, 4 times 3 times 2 times 1 times the 3 factorial. Now, if you work out one of these, think about how many arrangements we have. 1, 2, 3, 4, 5 arrangements of this. So I know I'm going to have to multiply whatever we have here by 5 because this is an or. It can be in position 1 or position 2 or position 3 or position 4 or position 5. That's the whole point. Okay, so they're ors. So you add them all up. So if you multiply one of these out, 4 times 3 times 2 times 1, well, wait a second. Isn't that just 4 factorial? Isn't that 4 factorial times the number of choices you have, which is times 3 factorial, right? But you're going to have to do this 5 times, right? So you can figure out this number, 4 factorial times 3 factorial. Let's just do it right now. 4 factorial times 3 factorial works out to be 144. That works out to be 144. Now, I can be smart and just go, okay, well, that one's 144, that one's 144, that's 144, that's 144. Well, how many 144s do I have? I have 5 of them. Okay, so I can either add 144 5 times or just go 144 times 5. and I get a number of 720 different arrangements of this with K, C, and N all being the same, right? Okay, K, C, and N all being together in one group. Now, let's think about this a little bit more. Let's think about this a little bit more. Let's turn around and start being a little smarter now that we know factorial notation. Think about this. I'll get to this one in a second, okay? Now, think about this. Look back at this problem. Look back at this problem, okay? I have KCN. I could just leave KCN alone for a second. I'm not going to mix it up or anything. Think about this. KCN could be in the first position, or the second, or the third, or the fourth, or the fifth. Meaning this, watch this. It can be in this position, the first position, 2, 3, 4, 5 letters left. There's a 4, 3, 2, 1. 4, 3, 2, 1. Remember, that's what we had. But think about this. If we treat this KCN as a group, and I can manipulate this like it was a tile, okay, like it was an individual letter. So KCN can be in that position, that position, that position, that position, 1, 2, 3, 4, 5 different positions. So the KCN could be here, 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 or here. Think about that. Wouldn't that give you 5 choices then for the first position? Wouldn't that give you 4 choices for the next position? 3, 2, and 1? Think about it. The KCN moves around just like we did here. A block, a block, a block, or a block, or a block. But here's the interesting way of looking at this. Isn't that KCN have 3 arrangements of its own? K, C, or N, C, N, or K, N, K, or C. See what I mean? You can rotate those around. So doesn't that first guy also have 3 factorial arrangements of KCN for a total of 6 arrangements? Of course it does. Then you can also arrange this 5 factorial different ways. I'm curious, will this give me the 720 that I had before? Let's try. 3 factorial times 5 factorial. 3 factorial times 5 factorial gives me 720. Oh my God, yeah, it gives me exactly the same way. So I've got 2 different ways of answering this problem now. I can set this up as an OR statement, like I did here, okay, and choose KCN to be in one of the 5 positions, or I can just say, yeah, you have 5 choices for the first position. It could be the group KCN or any other of the letters, right? Any other 4 subsequent letters. So that KCN then is chosen, if you think about it, as a letter. It's one tile, KCN. So you got 5 factorial choices for where the KCN could be and all the other letters, plus the factorial, the different arrangements of the letter KCN. 3 factorial gives you exactly the same number. So it doesn't matter which way you do this, you have an option of doing it this way or this way now. Totally 1000% up to you. Interesting, isn't it? I love the fact that you can do questions in different ways. Okay, so now let's get back to my question here that I'm going to be working with. Okay, let's clean this up. All right, now the cool thing with this question here is this. Look at this. It says, what if KCN cannot be together? They must not be together. So let's think about the word we're dealing with again. We're dealing with the word kitchen. Okay? We're dealing with the word kitchen. So if I take the K, the C, and N out, the K, the C, and N, what am I left with? 1, 2, 3. I'm left with 4 letters. So if you think about it, let's put those letters in right now. 1, 2, 3, and 4. Okay, so those could be any of those letters. Okay, I, T, H, or E. So if you think about it, I've got 4 choices for that letter. I got 3 choices for the next letter, 2 choices, and then 1. So in fact, I have 4 factorial choices for where those letters can be. But think about it. If K and C and N cannot be together, where could they possibly go? Well, K could be up front here, or K could be in between there, and one could be here, and one could be here, or one could be out here. Well, that's kind of interesting. So if you think about it, you have 1, 2, 3, 4, 5 positions where K, C, and N can go, but you only have 3 letters. Oh, okay. Well, guess what? Then you have 5 positions. You're going to pick 3 positions to fill those letters. This becomes a permutation. Makes it really super simple. 4 factorial on the letters here, right? 4 factorials on the remaining letters, which of course were I, T, H, and E. But you have 5 positions they can be in, but you only have 3 letters to pick from. Oh, well, that just makes all kinds of sense. So 4 factorial times the permutation of 5 pick 3. So let's put that into our calculator right now. 4 factorial, right, times the position of 5 positions, 5 alpha. Of course, we're going to use 7 here. Pick 3 for a total of 1,440 different arrangements with K, C, and N not being together. 1,440. Isn't that cool? Love this question. Wait till you see the next question when I do the same kind of thing, but now I'm going to have repeats. Woo! Wait for that one.